In the last section of 3.4, we are going to be factoring expressions. So let's first talk about what this word factor means. Remind ourselves. Remember, if we're talking about the number 24, the factors of 24 are 1 and 24, 2 and 12, 3 and 8, 4 and 6. Those are the factors of 24. The prime factors of 24 are found by doing a factor tree, starting with any two numbers. I'm going to do 6 and 4, 2 and 3. These are both prime, so you're done. 4, 2 and 2, both prime, so you're done. So the prime factors of 24 are 2 times 2 times 2 times 3. So what we're going to be doing in this section is you're going to be given a numerical or an algebraic expression, so something that has terms, and you are going to take out the greatest common factor that's in each of the terms. Let's start with a numerical expression. I like to think of factoring expressions as backwards distribution. What you're looking at right now is actually what your answer is going to look like. So if we have a problem like this, we know that we can distribute. You do 6 times 4 is 24, and 6 times negative 3 is negative 18. This is a numerical expression, 24 minus 18. So what's going to happen today is you are going to start with this, and you want to take out the greatest common factor, so your answer in the end looks like what we started with. So let's write another expression off to the right over here. Let's look at 24 plus 42. Now, there's actually, in my mind, 3 different ways we can do this. You can look at 24 and 42, and sometimes you're just going to know what is the biggest number that comes out of both 24 and 42. You know they're both even, so you know 2 goes into both of them. You know that 6 hopefully goes into both of them. I think about the other multiples of 24. I know 8 goes into 24, and 42 doesn't work for 8. I know 12 goes into 24, and 12 doesn't work for 42. So in my mind, I'm thinking, okay, 6 is the biggest number that goes into both. So what you're going to do is you're going to take 6 out of both of the numbers. So you have 6 outside. And then you ask yourself, 6 times what gives me 24? That would be 4. And then 6 times what gives me 42, or positive 42, and that's 7. So you took out the 6, and 6 times 4 gave you 24, and 6 times 7 gave you 42. If you distributed, you would get the answer that you started with. Another way to do it would have been to write all of the factors. So 24, again, is 1 and 24, 2 and 12, 3 and 8, 4 and 6. 42 is 1 and 42, 2 and 21, 3 and 14, no 4, no 5, 6 and 7. So when we look at this, 6 is the biggest number that went into both of them, so you knew that 6 is what you should have taken out. Or you could even do the factor trees. Let me draw those real quick. 24, again, we did 4 and 6, 2 and 2, 6 is 2 and 3, 42 is 6 times 7, 7's prime, 2 times 3. And when you look at what's the same between those two, this is a good review for GCF. When you see that you had your 2's the same and your 3's the same, 2 times 3 is 6. So again, you see in all of those situations that 6 is the biggest number that comes out of both of them. So you would take 6 out of that expression. So I'd like you to try a couple on your own and see how you do, and then we'll go to algebraic expressions. Let's start with 36 plus 12 minus 60. I want you to factor the GCF out of this expression. Okay, so I like to use the trees just because I think the trees show not only what you're taking out, but they also show what you have left. Obviously, if you know the biggest number that comes out of all of them, then you should just factor out the biggest number because you know it. But let's just look at the trees. So 36 is 2 times 2 times 3 times 3. 12 was 2 times 2 times 3. And 60 was 2 times 2 times 5, times 3 times 5. Okay, so the common ones, what we know we're going to take out, I'm going to circle. There's a 2, and a 2, another 2, 2, and 2, and a 3, and a 3. So 2 times 2 times 3 equals 12. So I know I'm taking 12 out of this expression. Now, what's great about doing it this way is that you don't really have to figure out 12 times what, because what's left is always what's left in your factor trees. You took all the other stuff out, you're left with just a 3 in the first one. You took everything out of the second one, which means you are left with 1. There's something there. You have to multiply 12 times something to get that number. And when you look at the last one, you see that you have a 5. So 12 times negative 5 will give you 60. So that should have been the answer that you got. Now, if you knew 12 already, you would have been asking yourself, 12 times what gives you 36, and that would give you the 3. 12 times what gives you 1. 12, that would have given you the 1. And 12 times what gives you 60, and that gives you the 5. Your final answer, though, is this expression. And you can recheck it by distributing to make sure the answer works out. All right, one more. All right, try 44 minus 56, and then we'll check it out. Okay, so I'm going to start with maybe the idea that you thought 2 was the biggest number. 4 is actually the greatest common factor of this expression, but 4 is not a common thing that you think of for the number 56. So let's say you just started with 2, and you took 2 out of this expression. 2 times what is 44, and that's 22. And 2 times what is 56, and that's 28. At this point, you should have noticed that 2 and 22 and 28 are both even. So it's not completely factored. You should notice that there's still more that can come out. So you didn't factor the greatest common factor. So you either have to take more out and multiply it by the 2, or you got to start over. Okay, so then if I look at the trees, The trees show me that 44 is 2 times 2 times 11. And they show me that 56 is 2 times 2 times 2 times 7. So I look at what's common. I have a 2 and a 2. I have a 2 and a 2. And nothing else is common. 2 times 2 is 4. So I know that I'm taking 4 out of this expression. What I have left here, or 4 times what is 44, is 11. And what I have left here is 2 times 7. 2 times 7 is 14, so it's negative 14. Or 4 times 14 is 56. Just making sure that you use all of your resources and all of the things that you know so we aren't making silly mistakes. All right, so let's add some variables. So the algebraic expressions are going to have variables in them. You're going to have something like 5x minus 20. Now, the only time you can factor out a variable is if there's a variable in both or all expressions. So in this one, your x is only in the first term, so you can't factor out an x and all. What you're going to have to do is just look at the numbers. You have 5x and 20. Now, I started with the simple one because I know that you can tell me right away that 5 is the biggest number that comes out of 5x and 20. So I'm going to take 5, and I'm going to say 5 times what gives me 5x. Now, what you're really looking at is just the coefficient. So 5 times what is 5? 5 times what is 5? Yeah, that's what I meant. Is 1. 5 times 1 is 5, and then the x is there. Now, because it's 1x, remember you don't have to write the 1, so it's just x. And then 5 times what gives you negative 20, and it's negative 4. If I'm going to check my work, 5 times x, 5x, 5 times negative 4, negative 20. And I see that that works. So this is the answer, 5 times x minus 4. You are going to have problems that have multiple things that you could take out. This is going to be to the extreme. How about that? If I give you 12 x to the 4th plus 16x to the 3rd minus 4x. Okay, so now you'll notice this one has numbers, coefficients in all of them, and even if it didn't have a coefficient, you know it would be 1. It also has variables in all of them. So you could take variables out of all of them. The same variable. That's important to note. They have to be the same variable. Okay, so let's talk about the numbers first. If we were to do factor trees for this, for 12, 16, and 4, I know that 12 would be 2 times 2 times 3. That's 12. And then what you have to remember is x to the 4th is x times x times x times x. Okay, that's the first one. 16 would be 2 times 2 times 2 times 2. And then x to the 3rd is times x times x times x. And then 4x would be 2 times 2 times x. So now when we're looking at what we're going to take out, I look that I have a 2, and a 2 that's the same, another 2 that's the same. I have an x, and an x that's the same. And now even though there's x's in this one and in this one, because there's none left over here, you can't take any more x's out. If you're going to factor something out of an expression, it has to be able to come out of all of the expressions. Okay, so what do I have that's common? 2 times 2 times x. which equals 4x. That is what I am taking out of this expression. All right, so if I take 4x out, 4x times what gives me 12x to the fourth? Well, if you see, I have a 3 and 3 x's. So it's 3x to the third. In the next one, I say 4x times what gives me 16x to the third. I have a 2 times 2, which is a 4, and an x times x, so it is 4x squared. The last one, 4x times what gives me 4x, you see that it's 1 because there's nothing left. So when we look at our coefficients in our answer, 3, 4, and 1, there's no numbers that come out of that. And then we have x to the third, x to the second, and there's no x in this one, so there obviously couldn't have been another x out of there. So this is our final answer. And this is the extreme. This is the hardest, the farthest thing that you'll get as far as factoring goes. Let's try a couple on our own. Okay, try them both out and then come back. 28 plus 35, 28x plus 35. So we're looking at 28 and 35 and trying to find the biggest number that comes out of both of them. If I have 28, I know that 28 is 1 and 28. 28 doesn't go into 35. 2 and 14. 14 does not go into 35. 3 doesn't. 4 doesn't go into 28. 5 doesn't go into 28. Actually, 4 does. I'm sorry. 4 times 7 is 28. And 7 does go into 35. So 7 is going to be the biggest number that goes into both of them. So I'm going to take 7 out of the expression. 7 times what is 28? And that is 4. And then you cannot forget the x, because 7 times 4x is 28x. And 7 times what is 35? And it's positive 5. So the answer you should have gotten is 7 times 4x plus 5. Looking at 9 and 54, I do my multiples of 9. I say 1 and 9, and I know that 9 goes into 54. So I can solve the problem with 9. I take 9 out. 9 times what is 9? And that is 1. And then it would be 1x. But remember, we don't need that 1, so we just write x. And 9 times what is 54? And that's 6. But there's an x again. Now that is weird. So when I look at that, I have to realize that I should have, from the very beginning, not just taken 9 out, but taken 9x out. So that changes this, all of the parts of the expression here. And I know it's 9x times what gives me the 9x. So it's not x anymore. The expression is actually 1. 9x times 1 is 9x. And 9x times what is 6, so, or is 54, and that is 6. Whoa, I made a lot of mistakes in my explaining there, so let's just recheck this answer. 9x times 1 minus 6, and make sure it turns out right. 9x times 1 is 9x, and 9x times negative 6 is negative 54x. Making sure it matches, it does. So it worked out. All right, now you're going to try this on your own. Good luck, and make sure you ask if you have questions.